Sue. Let's check out these questions that you sent me. And I apologize for the slightly late response, but I wanted to just kind of let everything come in because I know you're working through stuff last night. So, first one. Let's take a look at these definitions, and I'm going to tweak them a little bit. I think you're really, really close. You're just missing one little tweak. Number one, a relation is a function where the x values are unique in a list of ordered pairs. So just one thing I would say about that. A function is a relation. All right, so there's all kinds of relationships. Any set of ordered pairs is technically a relation. You know, like I could have just like two ordered pairs, 1 and 2, and I could have like 3 and 4. Well, that's a relation, okay? But a function is a specific type of relation where the x values are unique. So that's just my one little tweak on that. An equation, however, must have a unique x or y to be a function. One x input for one y output. And that pretty much is true, okay? And the reason why is because let's think of a horizontal line, right? And this is, the vertical line. The vertical line test. So if we're talking about a graph of some line right here, like let me just graph this function here in black, we could see clearly that for each and every x, there is one and only one y, all right? But it's not that clear. It's basically for each and every x that's a unique input. For example, this point and this point are the same with regard to the y-axis. So we can have two or more y's, right? We could have two or more f of x's because f of x is the same as saying y. We could have two of those. That's okay, but it has to be unique for every x input. So just two comments I just wanted to make about that definition. I hope that helps a little bit. Let's get into some of these questions that you've been asking. So let's talk about breaking all these down, talking about the domains, answering all the questions, and we'll go through. And basically, I think that you asked me kind of two of the same ones, but we'll go through them anyway, and we'll just see. So first one, we'll start with this one, 2.3.33, all right? So this is this guy right here. I'll blow this up. So we can see a couple of things. We know that it's constant over this interval. We can see that this is decreasing over this interval, and then it starts to increase again. All right, so we can answer a whole bunch of questions here. Now, number one, the domain of all of this is any x value. So literally negative infinity to infinity. Because this line is going to go to the left forever, that's negative infinity, and this line is going to keep going forever here. But don't think of it as, y values. Just because this is increasing, we don't care about that right now. We're talking about the domain. And that's the tricky part. You always have to keep thinking in your mind, what are the possible values of x? So this is going to go forever in this direction. It's going to get bigger and bigger and bigger and bigger and bigger, and eventually it's going to encompass all values of x. All right? Now the range is going to be from -1, the minimum value here, all the way up to infinity. So for the domain, by the way, because it is negative infinity to infinity, we just use soft brackets, right? By definition, infinity never really ends, so we can't really ever put a hard bracket there. That's just like a math convention. Here, though, let's talk about the range, and the range is included in part of this. So here, the line of this graph touches -1 on the y. And again, the range is with respect to the y. I don't care about 3 on the x right now. We're just talking about the range. So because the value of this function falls on that point, we have to use a hard bracket. Because right here at this point, this is 3 and -1. So if I use the soft bracket, that's saying that -1 is not part of this, right? So that would be incorrect. So that's kind of the big trick about brackets. If the value of the function or the line touches that value, we have to include it with a hard bracket. All right? The zeros, next one here, part C, the zeros of this function are the x-intercepts. That's just another word for x-intercept. It's another word for roots. So roots, zeros, x-intercepts, they all mean the same thing. And basically, what we're looking for is what point does this line cross the x-axis? Well, it crosses at 2 and 4. Just make sure to read the question because they sometimes try to trick you up here. They might say the left 0 is 2, what's the right 0? And you have to just blast that in. Y-intercept, same play. It's here at 8. That's the point at which this crosses the axis. And now let's take a look at some intervals. So over what interval is what's going on? When's it increasing, decreasing, and constant? And intervals, in general, are soft brackets because we're just generally describing this graph, all right? We're not going to get crazy. The range, yes, this falls right there on the range, but with intervals, we're just describing what's going on. And hopefully I'll elaborate this for you in a sec. So constant. A flat line means it's constant, so this is the interval from negative infinity, because it's going to go this way forever, all the way to 0. And again, we're talking about the domain here. We're talking about the x values. The interval from negative infinity to 0, this thing is constant. Now, use your imagination, but right at this point here, at 0, this is, 0 and 8, if you will, exactly at this point, for a split second, an instant of time, this doesn't move. It just stays there. Boom. Okay, so we can think about it constant, 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 and then it stops for an instant, and then it starts decreasing. So right here at this instant, we can't include that. If we used a hard bracket on 0, we're wrong, because it's not really constant anymore at this point. It's just freezing for a sec and then changing direction. So that's why we use the soft bracket. It helps eliminate all of that confusion. And by the way, if you want to study more about what happens exactly at this point, that's calculus. So go take a calculus course. I'd really encourage you to. It's kind of interesting. The next thing, let's take a look at the intervals over which this thing is decreasing. So it starts to decrease from here, and it decreases all the way to here, where again it kind of stops for an instant. So all of those x values are from 0 to 3, again with soft brackets. Then it starts increasing again from 3 all the way to infinity. This is going to keep going again forever, so 3 to infinity. All right, so I hope that helps with brackets too and all that stuff, but that's really what's going on. So when we're talking the range, yes, this is the minimum, this is -1, but this falls right on that, so we have to include that. But when we're talking about intervals over which stuff is increasing and decreasing, use soft brackets, just because of that point. Once it gets here, for that instant, nothing really happens. Okay, so we're going to use soft brackets on that. Any other values or any other questions here? We nailed the intervals. All right, let's talk about relative minimum and maximums. So, relative minimum and a maximum is relative to what we can see. We ignore the arrows. We know that it's going to go forever in this direction and forever in this direction. That doesn't really help us. But relative to what we can see, the highest point is right here. So what we would say, and again, this is a point in space. This is 0 and 8, right, on the coordinate axis. So what we do is we always say, and here's the question just so you can see it. The number at which f has a relative, well, we're doing maximum right now anyway. I didn't even ask maximum, but we'll talk about it. The number at which it has a relative maximum is right here. That's the x value again. The location of that is the x value. So we want 0. This has a relative maximum at 0. Now the value of that relative maximum is 8. So the way I always think of this is like with ordered pairs, right? An ordered pair has an x and a y component. We do the x first. Same with the relative maximum. So it wants the x coordinate first. This is the number at which it has it, or the location, and then this is the value of that maximum. Okay? Relative minimum is located here at 3. That's our location, and the value of that is -1. Okay, so again, I hope that really helps. Let's just evaluate some stuff now. F of -6. Well, in function notation, f of x is what we're using. So what that means is that f of x is essentially y. Okay, so f of -6, let me write this out. Here's how I think of that before I get into that too much. Y equals f of x, right? And everyone gets that. I hope everyone's like, y is just the same as f of x. That's great. So always think of that, y equals f of x. Because if they're saying find f of 6, that tells us we know what the x is. We need to find the y. That's how you can kind of keep that straight in your mind. Now, if they say, okay, f of x is 9, right? F of x is 9 or something like that. 9 equals f of x, or you could write it the other way, right? Doesn't matter. F of x is 9. Well, that tells us, well, there's your y. We need to find x. Okay, so this is the key. Just keeping that in your mind. That'll help keep everything straight if you don't like thinking about what f of x is or y or x, or they all kind of get jumbled up. Just think of that. So let's evaluate some points here. F of -6, see how the x is filled in there. So we know x is -6. We're going to find -6 right here. That tells us we got to go up and find the y. That gives us a value of 8. A couple of other questions. The values of x for which f of x equals 3. And see this right here? I'm trying to point to it. I'll minimize it. F of x equals 3. So we got to find the x. They're telling us the y. All right, so y is 3. What's the x going to be? So again, now we just go down. Here's 3. We go out. There's 2 values of x, which is okay. That's going to be at 1, 5. So 2 values there for that. And then lastly, is this function even, odd, or neither? So remember, it's even if the y-axis is the line of symmetry. In this case, it's not the case. This is shifted over too far. It's odd if it goes through a mirror image with the origin. Not the case here, so this one is neither. So you can tell that just by looking at the graph. Okay, so that's pretty much it on those. We'll talk about this other one too, 3.5 if you like. So again, let's do the domain range 0. So the domain of this whole thing is going to be negative infinity because this goes forever. They don't really include an arrow this time, but it does go forever. There's not a dot here to indicate that it ended. So the domain here, this is going to go from negative infinity all the way up to 5. And we have a shaded in dot, which again means that we have to use a hard bracket. The shaded in dot is part of the function. Okay, so negative infinity to 5, hard brackets on that one. Blammo. Okay, or 5.5, sorry. 5.5, I'm simplifying here. Now the range of this, we start at the most negative. So it's going to come from negative infinity, and it's going to come all the way up to 2. But again, check it out. That line falls on that value, so we have to include a hard bracket on that. Zeros are x-intercepts. It's going to be here and here, so at 5.5 and whatever that is, probably 1.5, something like that. F of 0, they're telling us what the x is. We need to find the y. So right there, here's x is 0. We go down, comes out to be negative 1. This is increasing from the interval negative infinity all the way up to 3. It's decreasing from the interval from 3 to 5.5, right? And again, hard bracket on that 5.5 if you want, because it kind of just stops there, but we have to include it with that dot, and it's never constant. And that's pretty much it, I think. Here's a good one, G. What interval or union of intervals represents the value for f of x is less than or equal to 0? Okay, so let's blow this up. And f of x, again, like if we go back to our notation here, y equals some function of x, right? So they're saying f of x is less than or equal to 0. So again, we're talking about the x values here, okay? So if we take a look at this, what it's saying is like, what are the intervals for all of this to be less than 0? All right, so the x values here, less than 0, that's all down here. Let me just reread the question. Yeah, less than or equal to 0. So here's 0 on the x. What are all the values that would fall underneath, like less than that or equal to 0? Okay, so basically here's 0, and all the values here would be from negative infinity all the way up to right about, let me just see, it'd be all right about to here, right? Because again, here's the 0 line, and we want that less than 0. So it'll come right up to about 0.5. So anything basically underneath the x-axis. That's what they're asking with that one right there. Relative maximum and minimum. This one doesn't have a relative minimum, but it has a relative maximum right here. The location of that is 3. The value of that is 2. What else we got? What values of x for which f of x equals 2? So again, they're telling us that y is 2, find the x. All right, y is 2, find the x. That's going to be 3. And is f of 4 positive or negative? Okay, so again, f of 4, well, that's x is 4. That's a positive number because we have to go up on the y to touch the line there. Okay, so a lot of information here, but I hope that helps you a little bit. Just think about y equals f of x and figure out what we're asking. Think about what goes on with the domain. If you have a shaded in point, you definitely want to hard bracket that. If the value of the function falls on that, you want a hard bracket on that. And if not, if you have a graph where there's a whole bunch of big changes going on, like something like this, well, then you know you're going to use soft brackets because it's going to stop for an instant. It's going to stop for an instant as well. So you can do hard brackets, hard bracket, and then hard bracket. Okay, I hope that helps. I know that's a lot of information, but let me know if you have any questions and we can talk more. Thanks.